Okay. Hello guys, welcome to another session of our most expected series, and this is the part 2. Okay, we had already completed 60 questions. So am I audible to you guys? Okay, you will find assertion reason questions over here in the second part of this PPT, because this entire one was one full mock test. Okay. So am I audible? Good evening to every one of you. Welcome back to this session. So please write a yes if I am audible to you guys. Then we can start. Please write a yes in the chat box. Join fast, guys. Okay, if I am audible, can you please type a yes in the chat box? Then we can begin. Okay, so I am Purbita Ma'am, your mentor, and I am pursuing my MSc from ICAR IARI New Delhi in the Division of Soil Science and Agricultural Chemistry, and we will be starting with question number 61. Okay, so what is Van Bemmelen factor? So as you guys know that while the estimation of organic carbon was done with the help of Barclay-Black method, he could not recover the entire percentage of carbon from the organic matter. Okay, so answers are already coming in the chat box. So he could not recover the entire percentage of organic carbon from the soil organic matter, and that is why we have to multiply it by a specific factor called Van Bemmelen factor. Now let's see what it is. So it is used for the estimation of the soil organic carbon from the soil organic matter, because the soil organic matter contains approximately 50% of the soil organic carbon, and if you divide 100 by 58, then you will get 1.724. Okay, so from here the factor comes. Very good. Now our next question is two organisms within a species mutually benefiting from each other. So you see that it is given within a species. Okay, that means in the same species. So we have mutualism. Mutualism means a synergistic relationship. Okay, so already answers are coming. Okay, very fine. Now mutualism means here also there will be a synergistic relationship in between two different organisms. So is in case of cooperation. But as it is mentioned within a species, the answer will be cooperation instead of mutualism, because it will occur in between different species. Okay. What is amensalism? In case of amensalism, if one partner has no benefit or no harm at all, then the other will obviously be harmed. So it is 0 and minus. So is commensalism. Commensalism, one partner is neither benefited nor harmed and the other partner is always benefited. Then we have predation. So in case of predation, one is positive and the other is negative. The positive one, it is called as your predator. Okay, and the negative one is called as your prey. Similar to parasitism. So in case of parasitism also, one organism will be benefited and the other organism will be harmed. So the one that is benefited is called as the parasite and the one that is harmed is called as host. Okay. So the correct answer will be option number B, that is cooperation or proto-cooperation. Okay. So you can always read this slide over here along with the explanation. Now, Complex compound produced in rhizosphere by the roots or through bacterial degradation. So, this has been directly taken from the soil biology portion. Complex compounds produced in the rhizosphere. So, what is the rhizosphere? That is the root zone of the plant. Okay, the soil which is in direct vicinity of the root zone of the plant. Okay. Okay, already answers are coming in the chat box, and it is secreted through bacterial degradation. So, it cannot be secretion. Okay. Mucilages are what? These are the compounds that are produced through metabolic degradation, right? And mucigels are mucilages plus soil. Mucilages plus soil particles together are mucigels. So, the correct answer will be option number B, right? So, roots, they will produce exudates. Exudates are what? The chemical compounds that are leaking. So, in case of exudates, the chemical compounds will only leak. Now, secretions are those that are released through plant metabolic processes, whereas mucilages are the compounds that are produced through bacterial degradation here. But often students confuse the mucilages with the lysates. Okay. So, see here, these are, in case of lysates, you will not have this term called complex. The complex term will be absent in case of lysates, but it will be present in case of the mucilages. So, the correct answer will be mucilages rather than that of lysates. Okay, Spurthi, got it? Fine. Now, who isolated bacteria from the root nodules of legumes which were the agents of nitrogen fixation? So, what did Liebig do? Liebig, he actually gave the law of minimum, which is related to soil fertility and agricultural chemistry. Bossingholt. Bossingholt is termed as the father of what? I'll keep that open for you guys, that option. Now, Beijerinck was again another scientist, and he did what? He isolated the bacteria from the root nodules of legumes, and he first named it as Bacillus radicicola, right? He did not name it as Rhizobium. Okay. So, let's see what is the answer. It is option number C, not B. Okay. Bossingholt, he actually observed, but he never isolated the bacteria. And who is the father of soil microbiology? He is Vinogredsky. Vinogredsky. He is the father of soil microbiology, and he actually was the first one to culture the microbes on a plate to isolate them. But here we are specifically talking about the nitrogen fixing bacteria, not the entire biological community as a whole. So, the correct answer will be Beijerinck, but not Bossingholt. Okay. Now, what did Whitney do? Whitney gave the concept of nutrient bin in soil, okay, related to soil pedology. Now, nitrifying bacteria is, so what is nitrifying bacteria? Now, tell me, what are obligate bacteria? Obligate means they will do that process irrespective of the environment. So, if it is an obligate autotroph, that means, autotroph means what? Autotroph means it will take its carbon from carbon dioxide, okay, carbon from carbon dioxide. So, this is the source of energy. So, sorry, this is the source of carbon, okay, and if it is photoautotroph, then the energy will be sunlight, right? So, they have to act as autotrophs under each and every environmental condition. So, let's see whether you are giving the right answer or not. What are heterotrophs? So, for heterotrophs, their carbon source is not carbon dioxide, but any other organic compound. And for facultative creatures, that means they can either act as autotrophs when the conditions are favorable, or they can act as heterotrophs when the conditions are unfavorable. So, let's see. It is option number A. Now, why is nitrification or nitrifying bacteria an obligate autotroph? It is because, you see, for the process of nitrification, the rate in the soil where oxygen is not a limiting factor. Okay, oxygen should not be a limiting factor. So, it is obligate autotroph, and if I want to be more specific, then it should be a chemoautotroph. Okay, it should be a chemoautotroph if I want to be more specific. Got it, guys? Got it? And the first process, so this is all about the nitrifying bacteria. That means nitrifying bacteria means they will convert this ammonia into nitrate, into nitrite and then nitrate, right? This is the nitrifying bacteria. But we have two other processes going on. One process is called aminization. Then we have ammonification as well. Okay? Aminization and ammonification. So, aminization, it is the conversion of proteins into amino acids. Proteins into amino acids. And this is done by a group of heterotrophic bacteria. Whereas the process of ammonification is where the amino acids are converted into ammonia or ammoniacal form. So, this is again done by several autotrophic bacteria. And this ammonia, if it enters into this phase of nitrification, then it will be chemoautotrophic. Got it? Similarly, we have another process which is called amination. So, what is amination? This amination is nothing but it is the reverse, where the amino acids will be incorporated or assimilated into the plant body or the bodies of microorganisms as protein. So, it is just the reverse of aminization. So, these all bacteria you have to remember that what is the nature of all these microorganisms. Okay. So, here the explanation is given. You can see from the slide and read it at your leisure time. Now, what is the name of indicator used for organic carbon estimation? So, we are estimating organic carbon, and here I should mention the name of the process, oxidizable organic carbon we are measuring through Barclay and Black method. Okay. Oxidizable organic carbon we are measuring through Barclay and Black method. Quickly give me the answers. So, here I am talking about the indicator. So, let us see potassium chromate. So, what it does? The potassium chromate is used in the organic carbon estimation, where this potassium dichromate is used, K2Cr2O7. So, this Cr2O7 2 minus ion, it is getting reduced to Cr3 plus, okay, with the help of chromic acid. So, it is not an indicator. Methyl orange. So, methyl orange is generally kind of an acid base indicator, you can say. EBT, erichrome black tea. Erichrome black tea, we use it in case of varsenate titration, where we want to determine the amount of calcium and magnesium. Okay, we use it in varsenate titration. And finally, we have diphenylamine. So, this diphenylamine is actually the indicator that is used for organic carbon estimation, and then it reacts with ferrous ammonium sulfate. Ferrous ammonium sulfate, the diphenylamine, it is an indicator, it will actually measure the reaction between ferrous ammonium sulfate and that reduced chromic acid. So, the correct answer is it should be D, that is diphenylamine. Okay. Now, Barclay and Black method is mostly used for the determination of. So, we are already seeing that it determines organic carbon nonetheless, and it should be oxidizable organic carbon. That means the part of the organic carbon that can be converted into carbon dioxide specifically. Now, can anybody tell me the available nitrogen we can determine by which method? Available nitrogen and the available potassium. So, the available potassium we can determine it by Hanway and Heidel method, where we use neutral normal ammonium acetate solution, that is 1 normal ammonium acetate at a pH of 7. And the available nitrogen we can determine it by Subia and Asija method, or we can also go for this Geldal apparatus, that is total nitrogen determination. Now, in case of available sulfur, we generally go for BaCl2 method. Okay, BaCl2 method, and we also use gamma cassia for that. Yes, Geldal method is there. Now, let us see. So, these are all the different kinds of This is the entire process of organic carbon estimation that is given over here. So, you can go through this. Now, indicator used for the determination of calcium plus magnesium. So, I had just mentioned that this calcium plus magnesium we are determining, but there is a catch in the question. So, while determining, okay, the option, okay, Spurti is saying A, let us see. So, while determining the amount of calcium and magnesium, first we determine the magnesium concentration, okay, and then we determine the calcium plus magnesium concentration, and to find out the calcium concentration, suppose this is B, suppose this is A, we actually subtract it, okay. Phenolphthalein is, again, I had not mentioned this, so this is an acid base indicator and it will give pink color. It will give pink color in a basic solution, and we generally use it for the determination of carbonates or bicarbonates. So, Erichrome black tea is used for the estimation of calcium and magnesium. Fine. Now, read the following statements. So, read it along with me, guys. Sheath erosion is a type of water erosion. Very good. So, it is also termed as the cancer of soils, okay, or the erosion that is not detectable by the farmers in the field because the entire topsoil layer is being washed away. So, it is very dangerous. Muddy runoff is a feature of splash erosion. Fine, after splashing, the rainwater will come into contact with those fine particles and it will lead to the formation of a muddy runoff. Okay, so Bangala is also saying that option number A, statement 1, 2, 3 are correct. So, the real erosion is an advanced stage of gully erosion. This is not correct because gully erosion is an advanced stage of real erosion. Remember, the reels that are formed, you can easily pull your farm back into the original structure with the help of tillage or other equipments. But the gullies, okay, they will ultimately lead to the formation of ravines and they are so deep that normal tillage is not possible. Universal soil loss equation, E is equal to F into ICKLV. Okay. So, let us see. So, option number D is the correct answer. That means, no, I am so sorry. It will be real erosion is the advanced stage of gully erosion. This is not going to happen. So, option number 1, 2 and 4. I am sorry. Okay, this is correct. This statement is also correct, and the universal soil, this is for the wind erosion, right? This is for the wind erosion. The normal one is RKLSCP, right? So, I can only say that option 1 and 2 are correct, but 3 and 4 are not correct. Okay, 2 is a correct statement. Muddy runoff is a feature of splash erosion, no worries. Only 1 and 2, yes, only 1 and 2 will be the correct answer. Okay, now can anybody tell me that who gave this universal soil loss equation? Who gave this universal soil loss equation? It was given by Wisheimer and Smith, right? They gave the universal soil loss equation. And the approximate soil loss in the Indian context is the 11.2 tons per hectare per year. It should be the annual loss of soil. Okay, it is the permissible loss, but in actual condition around 15 to 16 tons per hectare per year is lost, okay, each year by erosion. Now, given below are the two statements, one is labeled as assertion and reason. So, who was asking for assertion and reason type of questions? Here it is. Nitrous oxide, that is N2O. It is a trace gas that is formed during microbial processes of nitrification and denitrification. This is in fact true because when this denitrification reaction will happen, what will happen? This HNO3, nitric acid into nitrous acid into NO2, then NO, finally N2O and then N2, like this. So, either if your soils have some amount of oxygen present, then you will never get this pure elemental form of nitrogen. Generally, in the soils where we have intermittent flooding, okay, like that of rice cultivation, in that case this nitrous oxide gas will be emitted from the fields. So, obviously it is a trace gas. Natural emission can be increased by a variety of agricultural activities, including the use of synthetic and organic fertilizers, the production of nitrogen fixing crops and cultivation of high organic content soil, and the application of livestock manure. So, this cannot be increased, right? It can be decreased. You are using high quantity of organic matter. You are properly managing your livestock and other feed. So, in that case, natural emission will be obviously decreased, it cannot be increased. Okay. So, I think that the options haven't come over here. So, whatever nitrification processes, you can see that it will be option number C, that is statement 1 is correct answer, but 2 is incorrect. Okay. Because N2O must decrease. Now, coming to the next question. Here again another assertion reasoning type of question. Geographical information system links spatial data with descriptive information about a particular feature on a map. So, what is spatial data? Spatial data is something that is related to your geography, okay, that is present at a particular point in space, and it will link with the descriptive information about a particular feature on the map. That is very true. Information is stored as attributes of the geographically represented features. So, attributes are nothing but these are the information regarding a particular spatial feature that is located on the map. So, obviously option A will be the correct answer because both the assertion and reason are true, and because the data is stored as attributes, then clicking on the spatial data can give you the information about a particular feature. Got it? Now, here again another assertion reason type of questions. The probe of a neutron moisture meter is inserted into an access tube fixed vertically in the soil. So, vertically means in this direction. Now, it will contain a source of fast protons and a detector of slow electrons. So, it is not right. It will contain a source of fast neutrons and a detector of slow neutrons, which we often call as thermalized neutrons, right? Thermalized neutrons. So, actually the neutron moisture meter will detect that what are the percentage of slow neutrons that are returning after collision with the hydrogen atom, that is due to the water present in the soil. So, obviously the reason will become incorrect. So, option C will be the correct answer. A is correct, but R is not correct. Now, soils with high quantity of organic matter has high buffering capacity. Very true, because the soils containing high organic matter has a CEC or cation exchange capacity of approximately 200 to 250 milliequivalent per 100 gram of soil or C mole P plus per kg. Okay. Now, buffering capacity is high in the pH range of 4.5 to 6. So, this is also true. So, both of them are true. Okay. So, both of them are true, but let us see whether the assertion follows the reason or not. Okay. It does not, Spurti. So, she has answered option number A. Why not? Because they have mentioned a specific pH range, okay, and organic matter may or may not maintain your pH between 4.5 to 6. So, the reason does not explain the assertion in this question. Got it? Now, climate, it is an active soil forming factor. So, initially our scientist, father of soil science, Dokuchev, he actually gave this PCLO, right? The soil, it is a function of parent material, climate and organism. Later on, there was this Jenny and Joffe, okay. So, one actually divided the factors into, one actually gave this PCLORT and the other one divided the factors into active and passive. So, can anybody tell me who divided the soil forming factors into active and passive? So, actually the equation, this equation was given in 1941 and this active and passive division was made in 1949. Okay. Okay, Spurthi is saying Joffe, Vangala is also saying Joffe, fine. Now, climate is an active soil forming factor. So, we know that there are two active soil forming factors, one is climate and the other one is organism. And the parent material, relief and time, these are passive. Now, diurnal temperature variation will be more in polymineralic rock than monomineralic rock. So, polymineralic means it contains a combination of different minerals. So, obviously, the variation in temperature will be more. So, both the statement 1 and 2 will be correct. Okay. Now, given below are the two statements. Smectite fix K mainly in wet conditions. So, smectite will belong to this montmorillonite or montmorillonite we can say, and it will mainly fix K in wet conditions. So, this you have to answer whether or not it is true. Step K and constant rate K was given by Hellox. This is a true statement. Now, during the dynamics of ammoniacal fixation, we had assumed that there were two minerals, one was vermiculite and the other was smectite or montmorillonite. So, K fixation is higher in case of vermiculite kind of mineral than in case of smectite kind of mineral. It is right that statement 1 is incorrect because vermiculite is the only one that can retain K both in moist as well as in dry conditions. Why? What happens is that suppose this is your mineral structure and this is your K. So, whenever we will have water molecules surrounding that, the water molecules will tend to come in and form a hydration shell, and that hydration shell will lead to the breakage of the mineral and the release of the intermittently fixed K. In case of vermiculite, the interlayer interaction is so strong that even though water molecules are present, they cannot break the layers apart. Okay? But in case of smectite, it is already a highly expanding kind of clay mineral. So, it will lead easy access to water molecules and it cannot fix K in the wet conditions. Okay? Now, given below are the two statements. In the water drop method of structure analysis, a water drop of 4.7 centimeter is used. So, is centimeter the correct form? I do not think so. I think it will be millimeter, right? Wet sieving method of structure analysis is discovered by Chappell. But as far as I know, Chappell discovered dry sieving technique. On the other hand, Yoder, okay, he discovered the wet sieving technique. So, wet sieving technique is for, yes, Yoder. Wet sieving is for water stable aggregates and dry sieving is for the aggregates that are not stable in water. So, we use it to measure the susceptibility to wind erosion. So, both the statements are incorrect. Both the statements are incorrect. Now, pipette method of texture analysis was given by Robinson. So, this pipette method is nothing but international pipette method. International pipette method, and this international pipette method is actually the most standard method. Okay, most standard method for soil textural analysis. It is a bit time consuming. Hydrometer method of texture analysis is a rapid and most accurate method, and this was given by Boyoskas and Mick. So, quickly tell me the principles of these two methods. What is the principle of pipette method and what is the principle of hydrometer method? So, hydrometer method principle is the decrease in density, okay, right, that there is a decrease in density. Whereas, in case of, yes, pipette method, it is sedimentation, process of sedimentation, okay. So, option number C, pipette method is most but time consuming. That means statement 1 is correct and statement 2 is incorrect because hydrometer is not the most accurate method. Okay. I said international pipette is the standard one, but hydrometer is not. It is rapid, but and it is less time consuming, but it is not most accurate. Now, biogeoconiosis term was proposed by Docketer. So, this has been directly taken from new ISSS book in case of soil biology. and this line is mentioned. Okay, this line is mentioned. Alpha diversity is called local diversity. So, we can divide the biodiversity into 3 parts. Alpha, suppose this is a particular ecosystem, this is another ecosystem. Okay. So, the diversity that is present in between the ecosystem, it is called alpha. If it is present in these 2 ecosystems, then it is beta. So, the entire thing, okay, this is suppose a particular region, okay, region 1 and this is region 2. So, this is entire ecosystem 1, and if it is ecosystem 2, suppose another ecosystem, then the diversity that is in between these 2 ecosystems will be gamma diversity. Okay, gamma diversity. So, alpha diversity is called local diversity, that is also true. So, both the statements are correct. Okay. Now, conservation of species in its natural habitat is called in situ conservation. Very true. So, whenever it is ex situ conservation, that means you are conserving a species not in its natural habitat, for example, in zoo. So, when the last surviving individual has died, the species is called extinct. So, this is also very true, and this different classes of vulnerable species, extinct species, endangered one, okay, threatened, this has all been given by the red data book. Red data book of IUCN, okay, IUCN's red data book, International Union for Conservation of Nature and Natural Resources. So, both the statements are correct. Now, yes, see, drainage is the removal of soluble salts only from the root zone, and the gypsum factor is 1.25. So, let us understand what is drainage. It is the removal of excess water. Okay. Gypsum factor is when we are using gypsum as an ameliorating agent in case of highly sodic soils, you can say D, okay, statement 1 is incorrect, but statement 2 is correct. So, when we are applying that, we will have to multiply this gypsum equivalent with a fineness factor, and then we can get a gypsum factor, because theoretically and practically these 2 values will differ. So, whatever we derive theoretically, we will have to multiply by this and then apply it into the field. So, obviously option number D is incorrect, because leaching is the removal of soluble salts, not drainage. Okay, drainage is the just excess removal of water. Now, humic acid has a high E4 by E6 ratio than fulvic acid. So, this E4 by E6 ratio, it is measured at 465 nanometer and this is measured at 665 nanometer. So, these are nothing but the spectroscopic properties of humic acid. Okay. So, this E4 term, it suggests the presence of aliphatic groups. Okay. Aliphatic groups means they will not have any aromatic compound, single chain structures, no complex cyclic aromatic formula. But in case of E6, these are aromatic groups. Okay. Now, tell me which of the following has higher percentage of aromatic groups, humic acid or fulvic acid? Obviously, humic acid will have high aromaticity than that of fulvic acid. So, if this term in the denominator increases, then the entire ratio is bound to decrease. That is why humic acid has low E4 by E6 ratio and it borders around 3 to 5, whereas that of fulvic acid you can say around 6 to 9 is there. Okay. Real erosion is the most common form of soil erosion by water. So, that is true. This is false. Okay. So, D is the correct answer, that is statement 1 is incorrect, but real is the most common form of erosion. So, you can be asked what is the most common form, then you will have to say real, and if they ask what is the most dangerous form, then you have to say that it is sheet erosion. Okay, dangerous is sheet erosion. Got it? Next question, sodic soil in areas is sodic soil in India is dominant in the areas with a mean annual rainfall of, this should be around 200 or 120 centimeter, like that. Leaching is used to reclaim saline soil. So, leaching is used to reclaim saline soil. This is a true thing, because leaching will remove the soluble salts from water, and sodic soil in India is dominant. So, where sodic soils will be dominant generally in the arid or semi-arid regions, right? Arid or semi-arid regions where the precipitation is lower than the evapotranspiration, that will lead to the upward movement of salts and its deposition in the soil profile. Okay. So, let us see, option number A is the correct answer, because they had mentioned a very less, I think it will be somewhere around 20 to 120 centimeter of rainfall, somewhat like that. I will check and update you guys. So, the rainfall percentage is less in this question, that is it. Arid and semi-arid, so it is true. Next. Yes, option number A, fine. Denaturation of protein caused the change of primary as well as secondary structure of protein. So, this has been taken from biomolecules. So, we have also tried to include the minor portions in the mock test bundle or in this most expected series, so that none of the portions are left. Okay. Hemoglobin is on the other hand a quaternary protein, that is, it is a 4-degree scaffolded protein. So, let us see what is the correct answer. It is option number D. Why? It will affect the secondary, tertiary and quaternary structure, but not the primary structure. So, the primary structure of protein, the primary structure is actually the sequence of amino acids, okay, amino acids. So, while denaturation is happening, this sequence of amino acid change will not happen, but the secondary, tertiary and the other bonds will change. Okay, so option number D is the correct answer, that is 2 is incorrect, but 1 is incorrect, but 2 is the correct statement. Hemoglobin is a quaternary protein formed by iron, okay, it is the main element present in hemoglobin. So, he is writing option number A. Okay. Now, the process of oxidation will mostly occur after hydrolysis. So, this has been taken directly from the old ISSS book. Okay. So, the process of oxidation will occur after hydrolysis. Oxidation reduction processes are common in minerals containing iron, zinc and boron. So, let us see what you guys have to say for this question. Let us see what you guys have to say for this question. So, it is option number D, that is statement 1 is incorrect, but statement 2 is correct. The process of oxidation will mostly occur after hydrolysis. So, it may or may not occur after hydrolysis, right? Because in case of hydrolysis, what will happen, this H plus and OH minus ions, okay, it will come and break down a chemical structure, and after that your chemical structure may degrade and the weathering will proceed. Okay. Now, tell me another transitional mineral which is prone to oxidation reduction. This is manganese. Manganese is another mineral that is very much prone to the oxidation and reduction process. Okay. Now, the stability series of minerals was given by Goldrich. So, the same question we had covered in yesterday's class, although you had seen the answer. So, it was given by Goldrich in 1938, and the weathering index of hematite is 11. Okay. So, in the light of above statements, this statement 2 is incorrect, because it is not 11 for hematite. It is not 11 for hematite. We can see from here that for the hematite, you see that it is 12, not 11. And kaolinite, from this chart, you will have to remember this kaolinite. So, the kaolinite is has the highest weathering index among all the clay minerals. Okay. Kaolinite has the highest weathering index among all the clay minerals, that is 10. And the last is anatase, or the secondary minerals of boron, rutile anatase, like that. Okay. Sorry, titanium and boron. Now, nutrient index, it was given by Parker. This is true. So, he had initially mentioned this 1.5 to 2.5 to be the nutrient index formula. So, he did what? Low plus 2 into medium plus 3 into high divided by the total. Low plus medium plus high, whatever. Okay. So, it was from 1.5 to 2.5, and later on, okay, somebody is answering option number A. So, later on, Ramamurthy actually changed this to 1.33 to 1.67, okay, this range. He changed it. Now, salt index was given by Puri. So, these both are true, and in salt index we measure it with reference to which salt? Na2SO4. So, both statements 1 and 2 are correct. Okay. Now, ammonia. Ammonia is used to measure the total surface area of clay minerals. Is it right? Is ammonia used for measurement? I think mostly it will be ethylene glycol, right? Ethylene glycol. Okay. Nitrogen cannot penetrate the interlayer of clay minerals. So, we are here not talking about the surface area of analysis. This line or this assertion reason statement, it has been taken from the BET equation in old ISSS. Okay. BET equation in old ISSS, and there they had a line that although nitrogen cannot penetrate the interlayer, it will only be absorbed on the surface. This ammoniacal molecule can be used to measure the interlayer of the clay mineral. Okay, so it will measure both the internal as well as external surface area, both, but this is not the correct explanation. Both the statements are true, but it is not the correct explanation. Okay. Now, next one. So, why aren't you answering in the chat box? Okay. Now, nitrate fertilizer is recommended to apply in the reduced zone of the soil. So, nitrate fertilizer means nitrogen will be in NO3 minus form. We cannot use it in the reduced zone, because in the reduced zone this will be immediately reduced to ammonia, and then it will lead to volatilization loss. Volatilization loss. Okay. So, we cannot do that. In the reduced zone, nitrate will be converted into ammonia and it is lost. So, R is correct, but A is not correct. That is option number D is the correct answer. Okay. Next statement. So, I want answers coming in the chat box. Okay. Areas with high rainfall cause the formation of acid soil. Generally, the acidic soils are accompanied by humid tropics. That means high rainfall must be there. The rainfall must be sufficiently high. Yes, so that all the basic cations are removed out of the soil profile. High rainfall will cause the leaching of soluble basic cations from the soil profile. So, both A and R are correct, and R is the correct explanation of A. Got it? Now, next question. Nitrification causes a decrease in the soil pH. So, while reading about nitrification, does it cause a decrease in the soil pH or not? And it is a two-step process. Okay, it is a two-step process. So, let us see. Nitrification will not lead to a decrease in pH because it will lead to the formation of OH minus ions. Okay. Whenever these ammoniacal ions will react with water and get oxidized, nitrate and the formation of OH minus ions will be there. Okay, so it will cause a decrease in the pH. That is not true. On the other hand, people often confuse this with this thing, which is biological nitrogen fixation. In case of biological nitrogen fixation, there is a decrease in the pH. Okay, so do not confuse between nitrification and the biological nitrogen fixation. Okay. Now, yes, option number D. Increase in the surface residue will cause the loss of nitrogen through denitrification. This has also been taken from old ISSS. Surface residue will cause more water accumulation and create an anaerobic environment. Obviously, in case of anaerobic environment, there will be more denitrification losses. So, option number A will be correct because the reason it justifies the assertion. Next. Soil compaction will reduce the microbial activity in the root zone. This is true. Compaction will reduce the macropores and thus impedes the oxygen diffusion in the soil. So, this question was PYQ of 2025, the year in which I gave exam, and NTA actually did not mark this to be the correct answer. It should justify the reason. The reason should justify the assertion. But NTA did not give that to be the correct answer, but here we had amended it. Okay. Now, lime is commonly used for the reclamation of acidic soil. This is very true. Lime means calcium carbonate, okay, or calcium hydroxide. So, any material that will contain calcium and magnesium. When lime is added to the soil, the exchangeable hydrogen, so this is also a PYQ, okay. The exchangeable hydrogen and aluminium ions on the clay organic colloid complex as well as that in the soil solution are displaced by calcium ions. So, they are talking about two kinds of acidity. One is exchangeable acidity and the other is active acidity. One is exchangeable acidity and the other is active acidity. Okay, so let's see. Both after applying the lime, both first active acidity will be neutralized and after that the exchangeable acidity will be neutralized because these calcium ions, they will, yes, Mangala, yes, Purti, right answer. The calcium ions will displace the H plus or Al3 plus ions that are present on the surface of the soil, okay, and it will neutralize the exchangeable acidity. Next, mulching will control soil erosion and improve the water retention. This is true. Intensive tillage based agricultural system has a negative impact. So, whenever it is intensive tillage, that means you are applying much pressure on your soil, okay. So, obviously it will have a negative impact, but the answer will be B because the reason does not justify the assertion. Are you getting it, guys? Is it clear up to now? Second, Darcy's law is valid for a steady and stationary flow process in the soil. So, if you are not in the master course, then I had taken a very detailed lecture series on this Darcy's law and the other laws governing the fluid mechanics in unsaturated flow. Okay. In a steady state condition, what will happen? This dq by dt, that means the change in flux with time is equal to 0. So, this is also called a steady state flow or stationary flow because the flux is not changing with time, okay. And when we combine it in a steady state condition, the potential and gradient at every point will remain constant. This is true. The flux is remaining constant, that means the hydraulic head drop per unit distance will also remain constant, okay. So, Darcy's law, it is valid for only the steady and stationary flow. In case of unsaturated conditions in the soil, we actually use Darcy's law in combination with continuity equation, okay. This is also called as Laplace's equation and we can get two equations. One is of Richard's equation where they had taken the water potential and the other is Buckingham's equation where they had taken the volumetric water content, okay. So, you have to remember this. So, both A and R are correct and R is the correct explanation. Next, effective rainfall erosion index of a given area is linearly proportional to the percentage of ground that is not covered by vegetation. So, obviously, if your ground is not covered by vegetation, then your rainfall intensity will be high, right? And your erosion index will also be high. Rain erosion index includes both the kinetic energy of the rain and the maximum 30-minute rain intensity, but in India this 30-minute rain intensity is not taken, instead 15-minute rain intensity is taken for Indian conditions, but for global conditions 30-minute rain intensity is taken. So, let us see, the answer is B because the reason does not justify the assertion, okay. Next, urea can be used as a foliar spray. This is true. And in foliar spray, this urea, CONH2 whole twice, often forms a compound called biuret, right. So, this biuret concentration in case of foliar spray, it must not be greater than 0.5%, okay. Urea is highly soluble in water, so that is why only it can be applied as a foliar spray in spray form. So, option number A will be the correct answer. Next, so answers have stopped coming in the chat box. I want you guys to be active and answer, okay. Saline soil is called white alkali soil. Sodic soil on the other hand is called black alkali soil due to the degradation of this clay particles and organic matter and it gives the soil a characteristic black color. white encrustation of salt is observed in the saline soil. So, R correctly explains option number A. Okay. Next, lime requirement is more in clay soil than in sandy soil. So, I do not know that whether you had gone through that concept in old ISSS, where they are saying that more the buffering capacity, more will be your amendment required. Okay, more will be your amendment required. So, if buffering capacity increases, then the amendment requirement will also increase. So, obviously, the clay has a high buffering capacity than that of sandy soil. So, lime requirement is more, and the R correctly justifies A. So, option number A will be the correct answer. Clear? Okay. Soils containing higher concentration of carbon dioxide than atmospheric air, this is true, and approximately they contain 10 times more carbon dioxide percentage than that of air. It is 0.25 percentage in the soil air, whereas in the normal air it is 0.03, and nowadays it has become 0.04 percentage. Okay, but whatever your carbon dioxide content in soil air is more, and that is the diffusion of oxygen in soil is decreased in submerged condition. This is not the true reason. The true reason is due to higher microbial activity and respiration. Due to higher microbial activity and respiration, the carbon dioxide content in the soil will be more. So, that is true. This is also true that it is decreased in submerged condition, but it is not explaining the assertion. So, option number B is the correct answer. Next, now we have brought about some match the following questions. See. So, first is your collagen. So, what is collagen? Is it present in the muscle? Is it present in the hair and nails, silk, insect wings? Where is it present? Okay, where is it present? See, we know for one thing that keratin, it is present in the hair and nails, right? So, just I will remove all this. So, keratin is present in the hair and nails, and fibroin is another protein. Fibroin is another protein that is very important in the silk. Okay. So, let us see from these two options we can do it or not. So, it is B and C. So, option number C will be the correct answer. Collagen is found in the muscles and the elastin is found in the insect wings. Okay, yes, option number C is the correct answer. Next. So, this is again another PYQ, hydrodynamics, aerodynamics, mechanics. Quickly tell me the answer, guys. So, which of the following scientists gave what? Okay, so the answer here is option number B, hydrodynamics, given by Bernoulli. From Bernoulli's theorem, we have Bernoulli's theorem for a non-viscous fluid. Acoustics means sound concept, Helmholtz gave. Kepler's laws in mechanics, and then viscous fluid, okay, Kepler, and then we had aerodynamics. Okay, so the aerodynamics is Prandtl. Okay, now in case of submerged soil, specific conductivity will increase first and it will then decrease. Specific conductivity will increase first and then it will decrease in case of submerged soil. Then in submerged soil, the pH will generally decrease. In submerged soil, the pH will generally, what do we know about submerged soil? That if the soil is acidic or if the soil is alkaline, we do not know that. In both the cases, the pH will come to neutral. So, in case of acidic soil, the pH will increase, whereas in case of basic soil, the pH will decrease, right? But both will converge and both will come at a neutral pH. Okay, so suppose this is alkaline soil and this is acidic soil. So, both will converge and it will come to a neutral pH finally. So, the answer will be option number C. So, it will tend to neutralize the pH of the soil. So, it will tend to neutralize the pH of the soil. So, R is not correct. But specific conductivity will first increase and then decrease. Now, why is that? Why is that? Because generally, what will happen? What is the reduction series? Right? This is the reduction series, that is oxygen, nitrogen, manganese, then Fe3 plus, Mn4 plus. So, up to this Fe3 plus system, Fe3 plus reduction oxidation system, the specific conductivity will increase. But once the Fe3 plus is extinguished from the system and entire part has been converted into Fe2 plus, then the sulfur will be active. Now, this sulfur is active at a very low redox potential. Very low redox potential, that means highly reducing conditions are there. And in that highly reducing condition, the specific conductivity is bound to decrease. Okay? So, specific conductivity will first increase up to the point where this Fe3 plus, Fe2 plus dynamics will be maintained, and when this Fe3 plus is totally extinguished, then it will again fall down. Next, actual evapotranspiration and potential evapotranspiration. It will depict the conduction of water deficit. If actual evapotranspiration is equal to potential evapotranspiration, then it is water surplus. So, what is potential evapotranspiration? It is the maximum amount of evapotranspiration that can be occurring on a particular vegetatively covered soil. Okay, maximum vegetative cover is there, maximum evaporation rate is there. So, that is potential, and actual is always less or more than the potential evapotranspiration. Okay. Now, let us see. Option A is the correct answer. If your actual evapotranspiration is even higher, that means it is surpassing the potential or maximum evapotranspiration capacity. So, water deficit is there. But if it is equal, then we can say that there is a water surplus, and it will be even better if the actual evapotranspiration is less than the potential evapotranspiration. Okay. Now, in case of deep tillage, carbon dioxide concentration will be higher in the upper soil than the shallow tillage. Okay. Tell me. More diffusion will occur in the evap case to the deeper depth. So, what do you guys suggest? Now, can you tell me that tillage, it increases temperature or decreases temperature? The tillage is bound to increase the soil temperature. So, tillage will increase the soil temperature, and in case of deep tillage, you are actually tilling to a far greater depth than that of the shallow tillage. So, let us see, it is D. Okay. Deep tillage causes the diffusion of gases into more deeper layer, and that is why the concentration of the gas is more in the upper layer. So, it will not be in the upper layer because the diffusion is increasing. Suppose if I have, this is the upper layer and this is the lower layer, and if I till up to this layer, then diffusion will happen up to this layer only, and carbon dioxide will be concentrated in this layer. But if I do the tillage up to this point, then there will be more diffusion. Diffusion means more exchange of carbon dioxide and oxygen, carbon dioxide and oxygen. So, in that case, your carbon dioxide will not be concentrated only in the upper shallow portion. Okay, so that is why, yes, it will increase the soil temperature. Very good. Okay, so that is why the deep tillage will not actually concentrate the carbon dioxide in the topmost profile, but this is correct. Reason is correct, but the assertion is not correct. Okay. If it were not the upper soil, but if it were the whole soil, then it would have been correct. Now, again, this is another match the following. Tell me, from blue vitriol only, we know that copper sulfate forms blue vitriol. Okay. So, 2 is D. So, in all the 3 options, the 2 is given as D. Now, tell me what will be the correct answer. What will be the correct answer? C. Option number A is the correct answer. That means this vitriol of Mars is this. Now, whenever there is clay, always remember that clay is associated with aluminium and silicon. So, whenever there is vitriol of clay, aluminium will be present. Okay, aluminium will be there. So, obviously, option number 4 will be B. Okay, whereas in case of white vitriol, it is actually the zinc sulfate heptahydrate. Okay, and in case of vitriol of Mars, we have the iron sulfate. Next, SPOT or SPOT is a hyperspectral satellite. AgriAddict is a hyperspectral satellite. So, this has been taken from treatise, you can say from old IEEE, it is also there. So, SPOT is not hyperspectral. It is multispectral in nature. Got it? Now, these are the match the following questions. Indian Institute of Veterinary Research. Okay, Indian Institute of Soil Science, Central Tobacco Research Institute and Arid Zone Research Institute. So, Tobacco Research Institute is obviously present in Rajmundry. Okay, right? Then Indian Institute of Soil Science is present in Bhopal. So, 3 is A, option number A. So, option number C is the correct answer for this particular question. So, these are our courses and you can avail them so that you can get a brief idea what your preparation status is, as JRF is already knocking at the door. All the best. Now, it is given, so it is actually Vegetable Research Institute, I am sorry, not Veterinary Research Institute. Now, coming to this. So, we have different silica sesquioxide ratios, okay, the ratio of silica and sesquioxides and the different forms of clay minerals. So, let us see. So, 1:4. Obviously, it will be orthosilicates or nasosilicates we can say, where there is no oxygen sharing. So, SiO4, SiO4 minus 4, sorry, SiO4 minus 4, right. Then, this 1:3 or 4:11, it can go for ionosilicates. This is for single chain and this is for double chain. For the tectosilicates, we have SiO2, for example, quartz, and 2:5 is the phyllosilicate mineral group. Okay. So, from there you can do the options, that is option number C. Yes, everybody has stated correctly. Option number C is the correct answer. Now, do this. We have the different bark densities and we have the different soil types present. So, in case of the coarse textured soil, obviously coarse textured soil, we have the bark density greater, okay, because compaction is more or porosity is less, whatever, porosity is less. So, coarse textured soil will have 1.4 to 1.7, whereas fine textured soil will have less bark density. Peat on the other hand, because it is an organic matter, it has very less bark density of 0.5, whereas compacted soil have 2 as a bark density. So, it is all in gram per cc or megagram per meter cube. Okay, unit is gram per cc or megagram per meter cube. Now, coming to the next question, these are the different neutralizing values that are present and these are the compounds. So, what is neutralizing value? The amount of calcium carbonate that is required to neutralize the acidity of 100 kg of a soil. So, it is actually the amount of calcium carbonate divided by the amount of that particular amendment. Okay, so it is with respect to the calcium carbonate into 100. So, obviously for calcium carbonate this value should be 100 because it is an entire number or 1, and the more the molecular weight of a particular compound, the less will be its neutralizing value. Okay, so let us see what is the option. Yes, it is B, Mangala. That means in case of option B, so 1 is obviously B, then the 2 is A. Now, this has a particularly or relatively less molecular weight, lesser molecular weight, whereas CaSiO3, it has the highest molecular weight, so it will have the lowest neutralizing value among all of them. Now, arrange the following in increasing order of water use efficiency. So, surface irrigation, it will have the least one, okay. Then we can have sprinkler, then we can have drip. So, if in sprinkler we have 60 to 70%, and in drip 80 to 90%, and in pitcher pot irrigation, it has the highest irrigation efficiency. So, CDAB will be the correct answer, okay, CDAB. Then, correct sequence of wind erosion process. So, obviously it is saltation, then or so correct erosion, correct sequence of wind erosion. So, first let us see what is saltation. Saltation is when the particles they will jump, okay. Suspension is when the particles are suspended. So this is less than 0.1 millimeter, you can say, in case of suspension, and the surface creep are the materials that are dragged. Okay, dragged dragged through the bed in case of wind erosion. So they are stating option number D, suspension, saltation and surface creep. Yes, right. But in case of water erosion, it will be saltation, suspension and surface creep. Okay. So you have to see that which erosion they are talking about. Next, what is the correct order of dominance of microorganisms in the soil? So it is dominance, not biomass. Not biomass, it is dominance. Okay. So if it is according to the dominance, then the bacteria will precede. Okay, then actinomycetes, then fungi and then algae. But if it is according to biomass, then this order will be followed. Okay, because fungi has the highest biomass among all of them. Next, in the absence of salts, the order of CEC. So this has been directly taken from the T.D. Biswa's book. Okay, and this is the lyotropic series if or not like salts are present. So when the salts are absent, then what will happen? And when the salts are okay, Spurti, let's see whether your answer is true or not. As far as I remember, if the salts are absent, then the order will be like this. But if the salts are present, then barium hydroxide will have more CEC. Okay, if the salts are present. Okay. Now coming to the next question, Hofmeister series. This is also called as lyotropic series of minerals. So this is a very straightforward question. Straightforward question, yes, they are stating option number A. Okay, so higher the size, the higher it will be in a lyotropic series. Okay, so this is for alkali metals. Okay, group 1. Now, arrange the following oxides according to their 0-point charge. Arrange the following oxides according to their 0-point charge. So, whether it is silicon dioxide or manganese dioxide, gypsite or goethite. Quickly the answer in the chat box, guys. So, you see here from this particular figure, silicon dioxide has a ZPC of only 2. Okay. So, it is given in order relatively. As you go down, the ZPC increases. Gypsite has the highest, okay, preceded by goethite, and then we have hematite over here. So, we did a question yesterday only that what is the ZPC of hematite, something like that, and silicon dioxide will have the least ZPC. Now, the order of reaction of elements under submerged conditions. So, I just said you the sequential or reduction ladder, that is this one. Okay. So, for these two elements, the EH will be negative, and for all these elements, the EH will be still in a positive range. So, this is the reduction ladder given over here and the ranges of EH. Please also remember the redox potential, which is in millivolt, because it is very important. Okay. Coming to the next question, what is the correct order of the stages of weathering? So, the stages of weathering were given by Mohr and Van Baren, right? We did it yesterday only. So, it is initial, juvenile, virile, senile and final, and in case of virile, the clay content will gradually increase. Clay content will gradually increase. So, this is the chart over here, yes, Vangala. Now, the correct order of global warming potential of different gases. So, the global warming potential, it is the amount of heat that can be absorbed by a gas with respect to that of the same mass of carbon dioxide. So, for the carbon dioxide, we will assume a value of 1. Okay. For N2O, we assume a value of 289. So, it is greater. So, this will be the correct answer. That is CFC, then N2O, then CH4 and then carbon dioxide. So, here the global warming potentials of different gases are given. You can go through this whenever you have time. Okay. They are stating option number. So, okay, now this will be option number A only, not B. Okay. Option number A. Now, who is regarded as the father of field plot experiment? It is Boussingault. Boussingault is the father of field plot experiment. Saussure actually discovered nitrogen. Okay, essentiality of nitrogen in 1804. Puri on the other hand just gave salt index, and Barber on the other hand, he actually gave the mobility concept of nutrients, or the root interception was also given by him. So, he is related to nutrient dynamics in the soil system. Okay, so this is it. So, this is the end of our mock test number 1, our most expected series number 1. So, if you like this session, please do watch it, and if you are really benefited from this session, then you can drop a comment in the chat box so that we can organize more sessions like this. So, I want you guys to keep coming and revising because JRF is knocking at the door. Thank you to each and every one of you, and if you have any of your doubts, you can always post it in the chat box and we can answer, okay, according to our convenience. So, thank you so much.